Welcome to the Infinite Hotel, where full means flexible. Picture this, a hotel, not your average roadside motel. Oh no, this is the Grand Hilbert Hotel, an edifice of the mind stretching onwards room after room into infinity. Room 1, room 2, room 1000, room 1,000,000, and it just keeps going, never stopping. Now imagine every single one of these infinite rooms is occupied. The no vacancy sign is blazing. Seems like a simple situation, right? No more room. But this is where the universe, or at least our mathematical understanding of it, starts to play tricks on our everyday intuition. This hotel, conceived by the brilliant David Hilbert, is a thought experiment designed to stretch our brains and challenge our perceptions of full. Why bother with such a fantastical place, you ask? Because Hilbert's hotel isn't just about cosmic hospitality, it's a profound exploration of the concept of infinity itself. Infinity! A word we toss around with casual familiarity, but what does it truly mean when we get down to the nuts and bolts, the actual mechanics of it? This hotel serves as our laboratory, a place where we can poke and prod at infinity, see how it behaves under pressure. It forces us to confront the unsettling idea that full doesn't always mean what we think it means, especially when you have an infinite amount of anything. It's an invitation to a journey beyond the finite boundaries of our daily experience. The paradox arises when we try to apply our finite world logic to an infinite scenario. In our daily lives, if a parking lot with 100 spots is full, it's truly undeniably full. You can't magically conjure another spot out of thin air. But Hilbert's hotel operates under a different set of rules, the rules of transfinite arithmetic, which is the mathematics of different sizes of infinities. It's a place where the seemingly impossible becomes demonstrably possible, where adding to an already infinite collection doesn't necessarily make it more full in the way our common sense would expect. It's a delightful headache, a beautiful puzzle that unlocks deeper truths about the very nature of numbers and sets. So buckle up your curiosity, because we're about to check into this extraordinary establishment. We'll meet the unflappable night manager, a true maestro of the infinite, who handles seemingly impossible situations with mathematical grace and a calm demeanor. Prepare to have your preconceptions challenged, your mind gently bent as we witness how this hotel, always full, always has room for more. It's a testament to human ingenuity, our remarkable ability to grapple with concepts far beyond our immediate sensory experience, using the pure power of thought to explore the abstract landscapes of mathematics and logic. Let's start with a simple scenario, a gentle introduction to the hotel's peculiar ways. The infinitely full Hilbert Hotel stands before us, lights twinkling in every one of its endless windows. A lone traveler, weary from their journey, walks up to the front desk, hoping against hope for a room. What does our ingenious night manager do? Does he turn the traveler away with a regretful sigh? Not a chance. With a calm smile, he gets on the hotel's intercom system. He kindly requests that the guest currently residing in room 1 move to room 2. The guest in room 2 is then asked to move to room 3, and this continues for every guest. From room to room plus 1, a ripple of movement down the infinite line of rooms. Think about what just happened in this grand coordinated shuffle. Every single existing guest has moved one room over from their original accommodation. They all still have a room, a comfortable place to rest, just a different one than before. And what about room 1? The very first room in this endless hotel. It's now gloriously empty, ready and waiting for our new arrival. It seems like magic, a cosmic sleight of hand performed with numbers instead of cards. We added one guest to a supposedly full infinite hotel, and everyone is accommodated. This is the first mind-bending lesson of Hilbert's Hotel Infinity. Plus 1 is still the same size of infinity. Our finite intuition about capacity starts to crumble. Now let's raise the stakes a little, make things a bit more interesting for our manager. Instead of one weary traveler, a tour bus arrives. This bus isn't infinitely large, not yet, that comes later. It carries a finite number of new guests, let's say a group of 40 eager mathematicians on a conference trip, excited to discuss the latest theorems. Can the hotel handle them all at once? Absolutely. The manager, entirely unfazed by this larger group, makes another announcement. This time, every current guest in room is politely asked to pack their belongings and move to room plus 40. The guest in room 1 moves to room 41, room 2 to room 42, and so on. The result of this grand reshuffle is quite elegant. The first 40 rooms, room 1, room 2, all the way up to room 40, are now completely vacant, cleaned and prepared. They are perfectly ready for the 40 new guests from the bus who can check in without any fuss. Again, everyone who was already in the hotel still has a room, and the newcomers are comfortably settled. Adding any finite number of guests, whether it's 140 or even 1,000,000, to our infinitely full hotel is no problem at all. We just shift everyone down the line by that specific number. But what happens when the number of new arrivals is infinite? That's where the real cosmic fun begins. Now prepare for a truly astonishing scenario, one that really puts the Grand in Grand Hilbert Hotel. A bus pulls up, but this isn't just any bus. It's an infinitely long bus carrying a countably infinite number of passengers. Passenger 1, passenger 2, passenger 3, and so on. Stretching out as far as the eye can see, and then further still, forever. They all need rooms. Our hotel is already full. Remember, every one of its infinite rooms is occupied. Can our unflappable manager possibly find space for an entire infinity of new guests? This is where the true genius of Hilbert's thought experiment shines brightly, pushing our understanding of infinity to new exhilarating limits. The manager, a master of infinite logistics, devises a new, even more cunning plan. He gets on the hotel-wide announcement system once more, his voice calm and reassuring. He asks every current guest, the occupant of room, to please pack their bags and move to room 2. So the guest in room 1 moves to room 2, the guest in room 2 moves to room 4, the guest from room 3 heads to room 6, and so on down the line. Every current guest moves into an even-numbered room. This means all the original guests are still comfortably housed within the hotel, just in different specifically assigned rooms, leaving a pattern of vacancies. What's the consequence of this clever maneuver? This doubling of room numbers, all the odd-numbered rooms, room 1, room 3, room 5, room 7, and continuing on infinitely, are now completely empty. And how many odd-numbered rooms are there in an infinite hotel? An infinite number, of course. Precisely enough space for the countably infinite passengers disembarking from that infinitely long bus. Passenger 1 from the bus takes room 1, passenger 2 takes room 3, passenger 3 takes room 5, and so on. Once again, against all intuitive odds, everyone is accommodated. The hotel absorbed an entire infinity of new guests without breaking a sweat. But the cosmos loves a challenge, and it's not done testing our hotel's limits. Imagine one of these infinitely long buses pulls up to the curb. Each bus is teeming with its own countably infinite manifest of passengers. This represents an infinity of infinities, a truly staggering number of potential guests. Can the hotel possibly cope now? Our manager, ever resourceful, turns to the ancient wisdom of prime numbers. He knows there's an inexhaustible supply, 2, 3, 5, 7, and so on. Original guests are moved to rooms that are powers of the first prime, 2. For example, old room guests to room 2 to the power of. Passengers from bus 1 get rooms that are powers of prime, 3. Passenger on bus 1 to room 3 to the power of. Bus 2 uses prime 5, and so forth. Each guest receives a unique room thanks to the fundamental theorem of arithmetic, which guarantees unique prime factorization. The hotel, miraculously, accommodates them all. The reason these incredible feats of guest management are possible lies in the specific nature of the infinity we're dealing with in these scenarios. It's called countable infinity, or Aleph Null, 0. A concept brilliantly formalized by the mathematician Georg Cantor in the late 19th century. A set is considered countably infinite if you can, in principle, list all its elements one by one, creating a one-to-one correspondence with the natural numbers 1, 2, 3. The set of all integers is countably infinite. Even the set of all rational numbers, fractions, is perhaps surprisingly countably infinite. The guests on that first infinitely long bus formed a countably infinite set. It's the smallest level of infinity, yet it's still an unending, vast expanse. This ability to count or list an infinite set, even if the process itself would take an infinite amount of time, is what allows for the systematic reshuffling and assignments in Hilbert's hotel. We can always devise a rule, an algorithm to map existing guests and new guests to new rooms without missing anyone or causing any overlaps. The prime number solution for the infinite armada of infinite buses works because of the fundamental theorem of arithmetic. Every integer greater than 1 has a unique prime factorization. This uniqueness guarantees that no two guests will ever be assigned the same room number, even if many rooms, like room 6, which is 2 times 3 and not a prime raised to a power in our specific scheme, remain tantalizingly empty. It's crucial to understand, however, that not all infinities are countable. There are larger uncountable infinities, as Cantor also demonstrated. The set of all real numbers between just 0 and 1, for example, is uncountably infinite. You simply cannot list them all. There are demonstrably more of them than there are natural numbers or even rational numbers. If an uncountably infinite number of guests tried to check into Hilbert's hotel, our manager's clever schemes of shifting and assigning based on countable sequences would unfortunately break down. The hotel, for all its infinite rooms, couldn't accommodate such a deluge using these methods. This distinction between countable and uncountable infinities is a cornerstone of modern mathematics. So, Hilbert's paradox of the Grand Hotel is far more than just a delightful mathematical brain teaser or a quirky party trick. It's a profound illustration of how infinity behaves in ways that consistently defy our everyday finite intuition. It compels us to think more deeply and rigorously about the fundamental structure of numbers and sets. Understanding these concepts isn't just an academic exercise confined to chalkboards. It has far-reaching implications in fields like computer science, dealing with infinite loops or data streams, cosmology, contemplating the size and nature of the universe, and philosophy, exploring the limits of human understanding. It reminds us that the universe is rich with complexities and wonders that stretch far beyond our immediate grasp, and mathematics provides us with the elegant tools to explore these infinite frontiers.